for the end of third quarter. Your test will be next week. It was supposed to be on the Wednesday, but I guess it's an early out. Next week. Yeah, next Wednesday is an early out. So I can't do your test then. So I'm gonna push it back to the Thursday the 7th. Yes. Um. Well, we'll start chapter 7. Isn't the 9th the Saturday? Okay, so just that Friday. We'll just start chapter 7. All right. This is kind of important. If you wanted to come in after school and make up any part of your grade, that 8th is the last day that I will take any grade bring ups for third quarter. So the end of third quarter is the 14th. I have to turn in grades. I don't want on the 12th and 13th, I don't want 100 people in here trying to do bell work quizzes and test remediation. So I'm cutting you guys off on the 8th for making up any work after school. Okay, so if you're trying to bring your third quarter grade up, you know exactly what it is by the 8th. That's just next Friday. 2 weeks. 2 weeks Friday. Any questions about third quarter grades?
You're gonna put
the projects in.
Yeah. Remediation.
Yeah. Okay. I was focused mostly on bell work quizzes. So those are about ready. And then test remediation and then projects. And then there's a whole nother test. So there's a lot of grades. So technically there's 3 weeks still left in the quarter. So any other questions about third quarter grades? Okay, let's get right into notes then.
Yeah, can you go for 56 too? 56 or 57?
Alright, so on 56, the base here is 1/4, which is a number less than 1. That's going to make your graph swoop down low. Okay? So most of our logarithm graphs look like almost like a slow rising hill or a ramp. But if it is a base less than 1, it swoops downward. So your table is going to look something like we're going to do -2, -1, 0, 1, 2. And so when I do 1/4 to the x, 1/4 to the y power equals x. This is 1/4 to the -2 equals x. That's 16 equals x. 16, 4, 1, 1/4, 1/16. 57, you're going to start with y equals log base 2 of x. Then shift or translate down 1 unit. We did in class, so everybody should get 1 point at least for number 53 graph. Everybody that was here. Okay. And then I want to see some tables and some work for the other ones. I gotta see a table. Open your thing so I can see your work. Do you have anything to show me? You guys, there's no after school today, but there is the rest of the week, okay? Good. All right. Yeah.
Did you see mine?
What are you trying to do with it?
I have a question.
This sounds strictly today.
Miss Bobby, I have a question. You know how like whenever there's a vertical translation, you don't put it on the actual like chart or the X Y chart. You just have to do it.
All right, here is our notes for today. That's not the right slide. This is it. It's chapter 6.5, 1 through 27 odd. But please don't panic and start working on it. Like the process of going through the basic ones and then learning the properties, this is what's going to help you remember it longer. So try your best not to jump right into the assignment. That's not what's best for you with retention. So put your phone away all the way and keep it away forever. Okay, so here's the properties that we're going to use today. The directions are going to say expand and condense. So that means make the problem written out longer and make the problem written out shorter. So these are useful properties of logarithms. They're highlighted in your textbook here. Encourage you to read your book. You don't have to rely on me. If I make no sense to you, you should read the book. The book is very informative. Useful properties. So the product property shows this. Log base b of m times n. When m and n are mushed together like this, there's an invisible multiplication dot in the middle. That can be expanded into an addition problem. For example, Ventures, will you please put your backpack down? Ventures, you hear me? Will you please take your hood off and push your backpack down? Jaheim, take your hood off, please. No, I can't see what you're doing. I don't know if you're looking at a phone or not. Put your backpack down. Thank you. Yeah, weird. Okay. So, for instance, let's look at the product property. You don't have to write this example. We're going to do quite a few. Let's say it was log base 6 of 5x. That's really 5 times x, right? Well, you could rewrite this. This is the same as log base 6 of 5 plus sign in the middle, log base 6 of x. So you can take that 5 away from the x and make it 2 different logarithms. That's called expanding. And then a quotient property is the same thing, but it would be subtraction. So, and like I said, we're going to do lots of these, but let's say it was log base 6 of 5 over x. That is the same as log base 6 of 5 minus log base 6 of x. So you can take a fraction apart and turn it into a subtraction problem. Which might seem like kind of magical to you, but it's very much related to properties of exponents. So if you think about exponents, like this quotient leads to subtraction, right? Well, logarithms are exponents. So this quotient leads to subtraction, just like this one does. Okay? And properties of exponents like this, like x squared times x to the third, we rewrite with addition. Multiplication leads to addition. Same thing's happening here. This multiplication can be rewritten as addition because logarithms are exponents. So it's related. It's not as foreign as it might look. This one's very cool. If there's an exponent on your argument, you can rewrite it with the exponent in front. And you can just multiply the power property. So I'm going to leave these on the board as well here. And I have kind of little notes. Multiplication goes to addition. Division goes to subtraction. And the exponent can go to the front. So these are the main concepts we're going over today. I'll give you guys some more time to write this down. Writing them down will help you remember them longer. And when you're ready, we're going to do the gray box problems together. We're going to do these 4 and then all of these. So go to page 593 when you're ready. And we're going to put some of this into practice. You do need a calculator. You don't need a fancy calculator, but you need a calculator. Well, technically it's just subtraction. We're going to go to page 593. 593. Are you ready? This mine's blurry. Okay, so back in the day, mathematicians were limited to only certain values. And I'm not talking long ago. I'm talking like when I started teaching, the teacher next to me was like 60 years old. And she retired. And when she started teaching, the calculators did not do logarithms. So what they did is they had a big text, a big book. They would flip through and they would find the decimals listed there. It was things that people have done by hand and published. So they would use log books to help them get through like some trickier log problems. So when you look at number one here in the log book, it wouldn't have 5/8. But they would have the decimal for log base 6 of 5, and they would have the decimal for log base 6 of 8. So they would utilize the numbers they knew to get through more complicated problems. So again, when I look at that log base 6 of 5, I'm thinking 6 to what exponent is 5? And what this means is that 6 to the 0.898 is 5. So 6 to the first is 6. So to make 6 go down, we need a decimal exponent. That's that fact right there. All right. So this is a quotient. So we're going to do the quotient property of logs, and we're going to rewrite this as a subtraction problem. So log base 6 of 5 minus log base 6 of 8. Took it apart, made it logger. When you do that, one thing that is, I know, an issue with students not realize they're writing log twice. They end up just doing 5 minus 8, but that whole log is written again. Log base 6 of 5 minus log base 6 of 8. The 5 is on top. Okay. So now we're going to replace with the given decimal. So that's going to be 0.98 minus 1.161. Unless you've already said you have a calculator. You can do it by hand if you want, but just go ahead and do the subtraction and you're done. Question number 1. Alright, number 2, we're saying 6 to what power is 40? Alright, it's probably 2 point something because 6 squared is 36. So I don't know the answer. So I'm going to need to, all I really know is argument of 5 and argument of 8. So I'm going to rewrite 40 using 5 and 8. And it takes a little bit of creative thinking. There's no like perfect way that we can tell you every time this is how you do it. You have to think creatively. Part of 8 and 5 make 40. 8 times 5 is 40. So I'm going to rewrite this. Log base 6, 5 times 8. And everything is the same. 40 is the same as 5 times 8. And the reason we picked, you could write 40 as 4 times 10 or 2 times 20. But we picked 5 and 8 because that's what was given in the instructions. So whatever they give you in the directions is how you're trying to rewrite your problem. Now we're looking at the product property. Multiplication leads to addition. So I'm going to rewrite. This is where that word expand comes in. So this is the same as log base 6 of 5 plus log base 6 of 8. Write the word log twice. And then replace. Replace with the given decimal. 0.898 plus 1.161. So if you wanted to check this right now, you would do 6 with this exponent and see if you get a 40 out. So 6 to what exponent is 40? Apparently that. I wonder how close that is. I'm going to track it. 6 to the 40.04. That's how they used to do it. You get a lot more percent now. All right, number 3. 64. How am I going to get to 64 using base 8, Dennis? 8 times 8. You can do 8 times 8 or do 8 squared. I'm going to do 8 squared. So I show you how to do the power property. So this is log base 6 of 8 squared. 64 is the same as 8 squared. The power property says with exponents, you can just write it right in the front and turn it into multiplication. Power property. Multiply. So now I can take that 2, put it right down in front of the log. That's 2 times log base 6 of 8. And now I can replace that with the decimal. So 6 to the 2.322 is going to get us pretty close to 64. 64.10. That's the closest you get. 3 decimals. Alright, I'm going to pause and let you guys do 4. I'm going to rewrite 125 because that is from one group. I'm still not showing you how to calculate this on your calculator. Our next problems have variables in that. You can't do split? No, it's on the group box. No. Yeah. Was this the answer? Alright, what did we do with the 125? There you go, I found the third. Brianna, put your phone away. 125 is the same as 5 to the third. You're more familiar with that than you were a few months ago. We've been looking at these numbers for a while now. You guys are really expanding your understanding of numbers. So I'm going to take that 3, jam it out front. This is 3 times log base 6 of 5, and I know what log base 6 of 5 it was provided. So I do 3 times that decimal, and it gives me the answer. 2.614. So 6 to 2.614 is 125. Oh, that really goes really quickly. 2.3 to 2.6 is quite a difference. Alright, flip your paper and we're going to look at how to, this was called evaluate. Now we're going to look at expand and condense. One thing I haven't told you is what this LN is. Some of you have used the LN button on your calculator. If you look on this class calculator, the LN is right next to log. So you know, LN stands for natural log. So I wish it was NL, natural log. But I think this, in the original language, the word log came before the adjective natural. Anyway, it looks like a 1, doesn't it? But that's really a lowercase l. The natural log is log base e. So we we talked about how E means compound continuously. It's found in nature, the where radioactive elements decay, for instance, is it continuous decay. So base E is called natural log. And instead of writing log base E, mathematicians write ln. So you know ln is the same as log E. So when I'm starting out, I always replace it with log E, so I know I'm using the same properties. Okay? There's another one I haven't told you. If it just says log x and there is no number, that means there's an invisible 10. There's an invisible 10 there. So this is log base 10 of x. So for centuries, when mathematicians did logarithms, they only did base 10. It was really just scientific notation. It was used when they were like calculating distances using stars on ships. So really old math. So they never in their minds imagined doing any other logarithms besides base 10. So they didn't even write a number in here. So invisible means it's the original log, base 10, but they don't call it original log, that's what I would have called it. They call it the common log. So the log button on your calculator, that's base 10. Okay? Alright, let's get into it. You need a minute longer? So sometimes I write base E and sometimes I write base 10. Alright, so we're going to rewrite longer. Expand means rewrite longer. So the first thing I want to really indicate to you, because this is a common mistake, is that there is a dot in between there. That is multiplication. That is 3 times x to the 4th. Right? Even though you don't see that dot, it's there. So I'm going to change this to addition. This is log base 6 of 3 plus log base 6 of x to the 4th.
So yeah, you still could have done it.
Expand it out to addition. Then I'm going to do the power property and put this 4 out front. Log base 6 of 3 plus 4 times log base 6 of x. And that's a full expansion. Two properties are used. A lot of people will stop after the first step, but keep going. No. So now you have variables. There's no solving. It's just rewriting. So before we were just working with numbers and they were not x's. Now they're x's. Okay. So for this one, I'm thinking log base e of 5 over 12x. If you want to write it as log e, you can, and then go back to ln for your final answer, but that's all it is. Okay. So this can be expanded into subtraction. This is a product in here, so that can be expanded into addition. And I want to make sure that the 12 and the x are both in the denominator, so those two require parentheses. Without parentheses there, that would be wrong. Person, have you tried number 8 on 594? Person, you want to try it? It would help you. Copy of the examples. Alright, So this is log base 5 of 2 plus log base 5 square root x. Most students on their own are going to stop there. That's not done. Yes, this is a square root, and square roots can be written as rational exponents. So I'm going to rewrite this in its exponent form. This is x to the 1/2. Same thing. Right? Now I can take that 1/2 and move it out front. And now it's finished.
You had me the first half, not the one.
Any questions? I'm skipping that bit in the middle. So you know this is the invisible thing. There's a 10 there, and there's a 10 there.
You're supplying log 7. You're doing log 7 divided by log 4.
So we can rewrite this. So now we're switching to condensed. So one way you make it longer, multiple logs, and then the next way you make it smaller, turn it into one log. Expanded condensed. So this is natural log x to the 4th plus natural log y to the 8th. I'll expand one more time. Natural log x to the 4th times y to the 8th. You drop one of the logs out. Now 12 is very cool.
What did you borrow?
What's that?
Oh, compared.
Yeah. I think it's just a number. It goes down to one symbol. I don't remember. No. So this would be natural log 4 plus natural log 3 to the 3rd minus natural log 12. So I deal with that exponent first. That's writing that like it's an exponent. Natural log 4 plus natural log 27 minus natural log 12. 3 to the 3rd is 27. So that's natural log 4 times 27 minus natural log 12. 108. Natural log 108 minus natural log 12. Natural log 108 divided by 12. Natural log 9. That's when this is all introductory, right? When you do this again next year, it'll start flowing through pretty long problems, breaking them down and just coming out with one number. It's so satisfying.
No. I don't even remember what